Hi class, how are you today? That's greater than or equal to great! Alright, so the Learn It target for today is to solve inequalities using the properties of inequality. So last class we learned a bit about inequalities and some of the properties. Now what we're going to do is make inequalities just like equations, but with inequality signs, and we're going to solve them using properties of inequality that I will teach to you today. Alright, so first we're going to start with the addition property of inequality, which says if x is less than y, then x plus some number c is also less than y plus c. So if we add the same number to both sides, just like with equations, the inequality still stands. And that also works for the other sign. So if you say if x is greater than y, then x plus c will be greater than y plus c. The subtraction property of inequality, you can probably already expect what this is going to be. If x is less than y, then x minus c is less than y minus c. And if x is greater than y, then x minus c is greater than y minus c. And just a quick note, I haven't put or equal to, but because these work for less than and greater than, and we already know it works for equal to, then it works for all the inequalities. Now here's where things start to get a little bit different. First, we're going to do the positive multiplication property of inequality. So this one says if x is less than y and c is greater than 0, so some positive number, then x times c is less than y times c. And that works the other way as well. If x is greater than y and c is still greater than 0, then x times c is still greater than y times c. But that only works when you multiply positive numbers. Similarly, the positive division property of inequality says if x is less than y and c... I keep doing that. Alright, let's try this again. And c is greater than 0, then x divided by c is still less than y divided by c. And the other way works as well. If x is greater than y and c is still greater than 0, then x divided by c is greater than y divided by c. Now for the fun part, the negative multiplication property of inequality. So with this one, it says if x is less than y and c is less than 0, so some negative number, then x times c is greater than y times c. So what we're essentially doing there is multiplying both sides of the inequality by a negative number, and that, as you notice, changes the sign, the inequality sign. So it went from less than to greater than. So essentially, whenever you multiply both sides of an inequality by a negative number, it will switch the sign. Less than will become greater than, and it also works vice versa. If x is greater than y and c is less than 0, then x times c is less than y times c. Again, multiplied by a negative number, so we change the sign. Now for the last property. The negative division property of inequality pretty much does the same thing. If x is less than y and c is less than 0, again, a negative number, then x divided by c is greater than y divided by c. So we divided both sides by a negative number. So again, we change the sign. And if x is greater than y and c is greater than 0, then x divided by c is less than y divided by c. Alright, so that's all the properties, and now we're going to deal with, I'll do a couple examples just to show how it works. Alright, so we'll start off with 2x plus 5 is greater than 13. So first step we want to make, just like any normal equation, we want to subtract 5 from both sides. So we have 2x plus 5 minus 5 is greater than 13 minus 5. And that is true because of the subtraction property of inequality, which I'll label SPI. So when we combine like terms, that will give us 2x is greater than 8. Now, we want to get rid of that 2, so we're going to divide both sides by 2. Notice 2 is a positive number, so to do this, we are going to use the positive division property of inequality, which I'll call PDPI. So we take 2x, divide by 2, and that is still greater than 8 divided by 2. And when we simplify that, that will give us x is greater than 4. And then graph that on a number line. And I'll put a nice dot at open circle at 4 and shade to the right. So in this case, it's pretty much similar to solving an equation, just a little graph at the end. Before we move on, one more thing I want to mention, and I should have mentioned this last class. However, I'm making this video before I have taught last class, so hopefully I tell you guys. Anyway, so remember how we did set notation with solving equations? We're going to do set notation now with inequalities. So, make a nice brace. And the way we do this is we start off by saying x is real. So we say x is a real number. And then we draw a little line, and then we say x is greater than 4. And then we end the brace. That's how you write it in set notation. Just by saying x is a real number and x is greater than 4. Alright, next let's look at this problem. So, like usual, first we want to get rid of this negative 8. So we add it to both sides. So we have negative 3x minus 8 plus 8 is greater than negative 2 plus 8. And the property we used was the addition property of inequality, API. Then when we combine like terms, that should leave us with negative 3x is greater than 6. Now we look and we say we want to get rid of this negative 3 here. So we need to divide both sides by negative 3. However, it's a negative number, so we have to use the negative division property of inequality, which means we're going to write this as negative 3x divided by negative 3 is less than 6 divided by negative 3. So we change the sign. Then when we simplify, that should leave us with x is less than negative 2. And to write this in set notation, brace, x is real, bar, x is less than negative 2, and brace. Then draw our number line, and again we have an open dot because it's not equal to, at negative 2, and we shade less than, so to the left. Alright, that's it for this lesson today. Please, once again, remember to take notes on this entire lesson, and right now, take a picture of your notes and submit them to eBackpack. Thank you, have a good night.